Okay. There we have Patrick, right? I think there was somebody else too. All right. Okay, today, first thing we're going to do is look here at Evernote, because on the last video, I can't remember who sent me a email that told me that last one that we did in class, we didn't do the right calculations, and I went back. I can't remember exactly how we did it, but here is the correct one. If you look in your Evernote, you'll be able to see what I've just added this morning too. For week 3, so last class period, we did this one that says, draw a flowchart or write pseudocode to represent the logic of a program that allows the user to enter a value for one edge of a cube. The program calculates the surface area of one side of the cube, the surface area of the cube, and its volume. The program outputs all the results. I think we had the wrong formula or something. I can't remember for sure how it was. Was it one of you all that's here that sent me an email and said, oh, that calculation was wrong? Oh, it was the one that was sitting up here. I can't remember what his name is. A lot of people gone today. Maybe I've started too early. I started on time. Huh? I better go back and take a roll real quick too. Ooh, they're having fun, huh? Let's see. Not that one, or that one. Oops, come on. That thing's making that noise up there, isn't it? And it's not letting me type in. Come on. This isn't Monday. It's too quiet in here. You guys gotta. How many of you, this is your first day of class of a week? Anybody? Yeah, Kate, Thomas. So this is your Monday, huh?
Well, no, today is my Tuesday because my show's.
Because what?
No, today has to be my Tuesday because my favorite show's every night. So.
Oh, this is your favorite show. Let's see. What have we got? Intro. There, you're the one probably emailed me and said that the pseudocode. No, it wasn't. Said that it was wrong. Sorry about that. So, well, you were helping us with the formulas, weren't you? Weren't you the one on the last day? Somebody emailed me and said that it was the wrong answer. So I looked it up and okay, let me go back here. Oh, I actually have to add one if I go in and do that. I bet it was you. Did you tell me did you email and tell me the pseudocode, the formula was wrong that we did Thursday? Oh, that was the 2 people that were sitting up here. I thought it was one of you guys. It was somebody behind you. Matthew, was that you? No? Oh man, well, we'll see. Because I've got to look up how we did it last time. I have the correct one there, so we'll see if it was right. Now, see, I guess I started on time and I never do that. So here we got at least 2 more came in. Let me see. Oh, it's going to make me add the attendance here. Edit the register, blah, blah, blah. Make me add 2. Oops. Add a name on day 5. This is why I don't roll the whole semester because it's hard typing it in here. All right, so, but I do have to for a while because I have to tell when people quit coming. Okay, I don't see Joseph. He came by my office yesterday. Joseph, he's not here. Samuel's here. Dakota. Okay. I knew. Thomas is here. Oh, there's one more coming in. This one I took out of class because he's not. Oh, yeah, I just added him yesterday. Felix. Felix. No, not Felix. You're Bradley that just came in, right? Okay. Andrew Locke, he's not here. He sits by you, right, Aaron? Okay, and Aaron's here. I see Jamal in the back. Present. Matthew's here. Delonte's not here. Logan. Logan, that's you right there. Okay. Oh, Andrew did come in. There he is. I just passed your name on the roll sheet. Tanya's here. Oh, no, you're not Andrew. You're Joseph, right? Yeah. Okay. You switched seats because it was like Dylan. I was thinking that was right. Brevin's right there. Okay. Brandon's here. Caitlin's here. And Rashawn came in today. Let's see. Go back to Joseph. He was the only other one, I think, that came in. All right. Okay, so what, since I still don't know who told me that was wrong, we will go in anyway and look at it because I don't know if I have, oh, I bet I do in Lucidchart have the way that we did it. So let me copy this. And yes.
Was it Mr. Thompson or you that said okay?
It should have let you in there anyway. Did it go ahead and let you log on in? Yeah, I'm the one that has to, or it didn't on Lucidchart. What's it saying? Just a second.
It might work. Yeah.
It might work. Let me see here. Sometimes it tells you that you need an okay by me, and then now you used your Raider account, right? Okay, because if you don't use the Raider account, it won't let you in there.
Yeah.
Okay. All right. So let me see. That's not the one we did. Let me see if this is it. Because we did do some of them in Lucidchart. I'm going to see if this is. Yeah, here. Oh, but I don't think I put the output there. Okay. So the way that should have been, and I went ahead and added it into, into the Evernote. So you'll have this current one, but I can't recall if the only thing that's wrong is just that the formulas were wrong. And if that's the case, then that's not as big a deal, because what I'm trying to get at here is that we learned the flow. So what this one should have done, it asks you to calculate the surface area. Well, ask the user to enter a value for one edge of a cube, and the program is to calculate the surface area of one side of the cube and the surface area of the cube and its volume. So there'll be 3 calculations, right? Looking at it, there'll be 1 input, 3 calculations, and 3 output. So, oh, I didn't get that down in the right spot. Okay, so what, I can't remember if y'all have it written down, maybe you'll know. Input edge, so this could say get edge, input edge, whatever. This is the name of what? What's edge? What kind of value is that? That's called it's not a constant, it's a variable, right? So we chose edge because that's what it said in the problem. We could have used, why do we not use single letter variables like you did in math? Like E, A, why didn't we just say input E or input A? Why is that not a good thing to do? Come on. Yeah, just whenever you go back in algebra, you have to work with A's and B's and X's and Y's, and that makes algebra really difficult. But in programming logic, what we want to do is we want to use variable names that make sense with the problem, so that when we go back and look at the problem, it gives us an idea what we're doing. So in the word problem, it said, enter a value for one edge of a cube. So naming the variable edge, that's pretty logical, right? What's the name of this class? Fundamentals of Logic, right? Programming logic. But it really works across the board. So set side area, and here you don't have to use the word set. You can just simply say, put your calculation there and say side area. So they're using, this is another variable name, is equal to edge times edge. Surface area, you can say set if you want. Surface area is equal to 6 times side area. Volume is equal to edge times edge times edge. Then output side area, output surface area, and output volume. And what was another way that I told you, do you have to have 3 separate boxes for output? No. We can just use one parallelogram and say output side area, comma, surface area, comma, volume, right? So there's a couple different ways we can do it. Okay, so my phone's buzzing. So if I wanted to go ahead and, sorry about that, let me cut that off. If we wanted to do that with this problem, let me see if I can get all of it moved over here. Okay, so we want to make a flow chart. What's the start and stop symbol? No, the circle. It's an ellipse, actually. So it's called a terminator. So we come up here, we go start. And let's make it a little bigger. I'm assuming all of y'all knew that, just everybody didn't want to give the answer, right? Okay. Let's see. You didn't want to be the one that knew the answer. Let's see. Start. Well, I know what it did. Didn't highlight all of it, right? I'm not. Okay, let me get it all there. Now let's go. One of them is actually, okay. So I'm going to go ahead and pull another ellipse over here. You don't have to do it that way. Sometimes I do it that way. Sometimes I don't. I think I'm going to pull it over there. Let's see here. I have a new mouse that I'm working with too, a new trackpad, so it's different than before. Okay, so we'll just say maybe down there. So I know if I don't know anything else in the problem, I know there's always a start and a stop, right? So I can start there. Okay, so then it says input edge. So what shape do I use for input? Parallelogram. Good, thanks for the help. Here we go. Parallelogram. So here we would say input edge, since that's what we named our variable. We could say get edge. Remember, that's what we were using in the beginning instead of the word input. So you can do either way. Next step says side area equals edge times edge. So what kind of shape do I use for that? Side area, pardon?
Can you say that again?
Yeah, this second statement here, side area equals edge times edge. What shape do I use for that?
Square.
square. Good. That was Patrick, wasn't it? Thank you. The rectangle or square, whichever, at least the four-sided, well, I guess parallelogram is also four-sided, but it's not a form of a rectangle. Okay, come on. All right, so this one I'm just going to, because I don't want to type, I'll just do this, put it right here. If I can get this to move right. And let me get it a little bigger here. You can have it all on one line, but sometimes you gotta squish everything together. There we go. All right, so what's the next shape? Surface area equals 6 times side area. Rectangle again, very good. Anytime it's a process. Now in this particular problem, I don't have any ifs or any loops. So it's gonna be kind of a boring flow chart. All right, so this one goes my second. Anybody have any questions so far? You can all do this now, right? Better with your trackpad than I do. All right, so one more. Volume equals edge times edge times edge. What shape? What'd you say? Same, very good. Another rectangle, right? Because we have another process step. So we go here. Many of you are probably fast typists, so you can type it in faster and copy and paste, but not me. I like to copy and paste as often as possible. Right. There we go. Let's see. I probably could have duplicated that previous rectangle too. All right, so output side area. What shape do I need for that? Parallelogram, great. So anytime I have input or output, I'm going to use the parallelogram. Oops. And anytime I have a process statement, I use the rectangle. So here I'm going to just say output side area. I'm going to do it with one shape, surface area, comma, volume. Now, the thing that I always like to remind students of that is important is that whatever variable name that you use, that you start out with, it's really good if you make sure, well, it's not only good, later on you'll see how important it is, that you keep the variable name the same through all of your planning tools and whatever language you're coding in, whether it's Python, JavaScript, whatever it is, that you, whatever variable name that you decide upon, if I took these up here and I, oops, come on, that way. It is. And I changed it when I got down to the bottom, it would not, if I had a different variable name in my output, I wouldn't know, it wouldn't know what the variable was. So the thing is, if I capitalize a variable name, let's see, it's not wanting to do that because I'm off center, huh? There we go. Then I need to capitalize it the same when I copy it down, oops, as output. Oh, great. There we go. Doesn't like me this morning at all. Let's see. Let's get rid of that one now. There we go. So since over here in my pseudocode, I said surface, lowercase, then capital A for area, then I have to be sure that's the way I do it in my output, because that's the only thing that you want to be sure of so that they match. Because every language that you code in now, the case, whether it's capital or lowercase, it's case sensitive. So that means the names are totally different if you gave it side area without a capital. And what is this called when I don't put spaces in here? And what I call that? Whenever it's surface, capital A, REA, you know what that's called? Anybody remember? I probably said it maybe once or twice. It's called camel casing. That's what they call it because of the hump, right? So you go down your lowercase and all of a sudden you hump, okay? So it's all these little things that you'll hear different people use. It's called camel casing, and the reason we do that is so that we don't put a space in there. But another format that some people take on instead of doing camel casing is they put a underscore there. So any of that helps you. It's just do not put spaces in variable names, okay? All right, anybody have any questions about that? That one was pretty straightforward. Yes, Tanya.
So if you use all capitals, is that okay, or all lowercase?
Okay, yeah, all lowercase is okay. All capitals it will accept. But when we get into, like, our stamps problem had a constant variable, which meant that throughout the whole problem, the value didn't change, then that's kind of the standard for constant variables, is to use all uppercase. So it doesn't mean that the program won't run if your variable names are all capital, but it's just more standard where you can glance at it and say, oh, you know, and we're going to do one here in a minute with a constant. It's called a constant because that variable doesn't change throughout the program. You might say, well, why do you need a variable? Well, the thing, or why do you need a constant if it can't change, or why do you need to make it into a variable? Because if you have a long program, 300 lines, and it uses that value numerous times throughout the program, if, say, the price of stamps that was 44 cents went up to 47, which I believe it did, then you could just change it at the top of your program and it would follow through if it's in a variable. So we'll see that work here in a minute in one of the ones we're going to do in class. Okay, so right now, we're not worried about, even though I've introduced you to if then else's and loops, right now, for the rest of this week and next week, we're only going to talk about sequence. So you don't have to worry about whether I need a decision box in the first test, because you won't. We're going to do an input, some number of processing steps, and output. And you may have more than one input, and you may have more than one output. Okay, but we're going to get down sequential before we worry about, I just wanted to give you an overview of what you're going to be able to do by the end of the semester. Okay? All right, so now we're going to stop and we're going to say, okay, because I want to make sure, and I know some of you guys that have programmed before this, you've got this. You're like, oh man, we're going to do the same thing over and over. Well, you just have to kind of hang along for a little bit. Scroll down this way. Is that what you needed? Okay, so that's what we're going to work with is terminal symbols, rectangles, and parallelograms. That's all we're going to work with until next Thursday. That's when your first exam will be hands-on, okay? And that way you know exactly what to expect, because we're also going to do a project that will be just like what I'll want in your first test, okay? All right, so what we're going to do today is we're going to look at some more of these in-class problems, and I have 4 of them, and I'm going to divide you all up, and you're going to work on them for about, we're even a little further along. So you'll have about probably 15, 20 minutes. You may not even need that long. And whenever the one that you're working with decides y'all have finished that problem and upload it to Google Drive, then, and only one person has to upload your problem. So this, there's 4 of them, and there's 1, 2, 3, 4, 5, 6. Okay, 3 on this side. Y'all 3 work together on the first one. And then Thomas and Joseph and Aaron work on number 2. Then let's see how many we got. Oh, we got a whole lot more on this side, huh? Okay, the 4, Roshan, can you sit back there with Matthew and just while you work on that? And then the 4 of you guys work on number 3. Oh gosh. Okay, then the next 4 work on number 4. And one of you guys, Connor, you go up with them, and Jamal, can you come up here with these guys? You don't have to move lock, stock, and barrel if you don't want to. You can just move up there for that one problem. It's up to you guys. There's 2 seats up here, though. Oh, yeah, you're working with Dylan and Caitlin and Samuel and, oh, who's next to you? I forgot. I can't remember his name. He came in late. Let me think. I'm about to get everybody's, but I didn't have his. Okay, so Jamal, Roshan. Yeah, Jamal, even if you want to pull your chair around right there between those 4 guys, you can. And or if you just want to, however y'all want to work together, if y'all want to do it individually and then say, hey, here's what I got. I know y'all don't like to talk to ones you don't know, but hey, we're going to get some communication going in here. That's how team projects work. Patrick, you can pick whichever one you want. Oh, yes. The hardest ones are 3 and 4. So that's why there's more people on, so y'all can check it out. So somebody do the pseudocode and somebody do the flowchart. I want you to do both. I know it says flowchart or pseudocode, but I want you to do both.
What do we do on that?
Oh, which one is yours? 3? Yours is 2. Oh, okay. What I want you to do on number 2 is to actually what you'll have to do is both. You'll have to do the program above. You're 2? You're 3. Yeah, you're 3. So, yeah, you're 3. 2, you guys, what you have to do is so you're going to have to do both, right? The guys that are on number 2, you've got to take the one that has one calculation to compute the floor area. So if you want them to give you theirs, then you can do that. So you'll have to actually figure out the formula for calculating floor area, and then you take it and modify it. Y'all see that? But I give you the statement right there. Well, everybody on this side is just working alone. No talkers over here. Don't you know when you get in a real life job, you work on a team. And then there's a project leader, and he comes back and says, okay, what do you got?
You can actually put those in the same. I think. Go ahead and do it separate.
Because Patrick couldn't see what I was doing on the board there. So, all right. So we're going to start. Let's start with the easiest one so these guys have time to get there. I shouldn't say just the easiest one, but y'all got it done first, okay? You guys about done on number 2? Okay, so the one that they did, number 1, they had to use in number 2. So you guys see if this is what you did in number 2. Okay, this one, number 1, which one put it up? Brevin. Okay. Okay. MIN. It's supposed to say MIN. I just made up another variable name. Is what? Yeah. Number of minutes is why I did that. Right, Samuel. Okay. So you guys read your problem. Tanya, read problem 1, and then I'll give the answer to it. Or do y'all have it typed in up here? No.
It says
Okay.
draw a flowchart or write pseudocode to represent the logic of the program that allows the user to enter values for the width and length of a ring score in feet. The program outputs the area of the 40 square feet.
Okay. All right. So up here is the pseudocode they used. Input length, input width. And this is the area, but you say output area, but you never used it right here. So the only thing I see is that you say output area, but where did you calculate it? Okay. So you should have said area equals length.
On the calculation, it says define area.
Yeah, that's all it was. You had the logic correct. You just forgot one step, which would, when you get to output area, you don't know what area is because you didn't define it up above. So if we tried to run this in Python, since this one's real simple, well, I want to get through all of them first. And then we'll go back and put them in Python. Oh, did you do Python? Okay, he did Python, Brandon. Okay. So you probably in Python, you corrected this pseudocode, right? If you wrote it in Python, then you probably corrected what the pseudocode and flowchart didn't have in it. On the processing step, you just needed to say area equals. Okay, so where did you put it, Brandon?
I'm going to share with you a second.
Okay.
Go and do the next person.
Okay, so Aaron, do y'all have yours up there yet? No? Okay, what about 3? Does anybody in problem 3? Bradley has it? Okay, let's go to Bradley's is here. Oh, you need to fix your folder. Okay, it's work week 3, problem 3. Okay, so his, let me go ahead and download it so we can make it a little bit bigger here. Oops. And we can actually, I'll put these out there for y'all. Let me get them in here. Students. No, I put in-class problems. Okay, here we go. I forgot to save the first one. Okay, here we go. Show and finder. Okay, so this one says, let me get it up here. Make it a little bit bigger. Okay, so this one was draw flowchart or write pseudocode to represent the logic of a program that allows the user to enter values for a salesperson's base salary, their total sales, and commission rate. The program is to compute and output the salesperson's pay by adding the base salary to the product of the total sales and commission rate. Okay, so they input base sales, input commission rate. So the total pay is equal to the base sales. Oh, base salary. Yeah, that's right. Plus sales times commission rate. So in the order of operations, you wouldn't have to use parentheses. You might want to clarify which goes first because you want to be sure and multiply sales times commission rate first, right? And then add the base salary, and that would be the total pay. Then you would output or display the total pay and stop. Very good. Okay, the rest of you guys that were in number 3, did y'all get this? Do you understand? Follow it? Everybody work together? Okay. So here is the flow chart. Like me, we sometimes leave those lines off when they're a hassle, huh?
So all of you said parentheses are necessary or not?
They're not, but in viewing the calculation, I always use parentheses just to make sure that it's going to do it correctly. But multiplication should come first. So it would, but you could put parentheses around this, time or plus base sal equals pay. All right. Okay, you got yours up, Brandon, in the Python. Okay, then on number 1, let's see, Brandon, let's see, where you at? There you are. He did the Python for number 1. So this is how you would know, right here. This is how you would know if you
wrote it in there. I didn't upload it as a Python.
Oh, you didn't upload it as a Python?
I just
Okay.
pasted it.
Okay. You wrote it in the PDF. Okay. Save. That's fine.
So if you just open it, I can just copy and paste it.
Okay. Let's see. Oh, except that you can't exactly because
If
you've
you
got
open
to.
it in Google Docs, actually, if you go back to the Google Docs, just open that.
Okay.
And it'll give you.
Oh my God, I'm in preview, aren't I? Okay. Go back to Google and just open it here instead of downloading.
Yeah, and just copy and paste that.
Okay, so now I've got to open, let me open idle. Oops. Okay, so this is that first problem of figuring the area. So what Brandon did is he used the length and width when he's asking the user for it, but then it has to be converted to a number. And so he had an intermediary temporary holding for his variables. And then area equals L times W. So the area is area square feet. So let's run it and see what happens. Oh, it's going to tell me prob1.py. Let me put it where it's supposed to go. CIT13 in class. There we go. Okay, please enter the length. Let's say it was 5 and 8 for width, 40 square feet. Okay, so that was the Python for it. That one was pretty straightforward on the Python. Okay, so you see here is where he corrected it from what was in the pseudocode. That was, and the flowchart, it didn't have area equals, but when he went to run it in Python, he had to put that there. Okay. All right. You guys on 2 ready yet? Quite. Okay. Yeah, we got plenty of time here. We might go back and do Python. If one of you guys on 3 that we already uploaded wants to do the Python, try it. You can sure try the Python. Otherwise, we'll do it in class. You guys got, is it Joseph, are you uploading it? Oh, Bradley, see your folder right there? Name that BL. CIT1113 BL. Patrick, which one did you do?
I took a stab at number 4.
You did? Okay, so we're going to do that in just a second. Which one of you guys have 4 up? Dylan? I need one of them uploaded, whichever one's got it working so we can see it in class. Samuel, did you do it? Did you upload it?
I downloaded it.
Okay. Kay is not here today.
Okay.
Who did? Samuel did? Okay, let's see yours. There's 2 of them. Then also Dylan uploaded his too, I guess. Let's see. Where's Samuel's? There it is.
So I have it just right there. In class assignment.
Let's see if they're this. How they are. It'll let me make it bigger or not. Okay, so this problem, what was really confusing for them that they're having to struggle with is because if you read this number 4 problem, it says a mobile phone app allows a user to press a button that starts a timer that counts seconds. Now that statement right there, you actually don't even need to answer the problem, but it's just kind of giving an explanation of why you want this problem. When the user presses the button again, the timer stops. Yeah, those 2 statements you don't actually use in the problem. Draw a flowchart or write pseudocode that accepts the elapsed time in seconds and displays the value in minutes and remaining seconds. So for example, if the elapsed time was 130 seconds, then the output would be 2 minutes and 10 seconds. So that's the key right there. You have to know that the user has to input how many seconds, and however many seconds, you have to have a calculation that will output the number of minutes and the number of seconds. So this solution assumes minutes is an integer and has been truncated. Okay, so it's saying that when you divide, it's not going to tell you how many seconds are left. Okay, so what he did, and I think, and you tell me, Dylan, if yours is any different, I think it'll be about the same. Input E time, so this is just a variable that we used to represent elapsed time. So we're going to ask the user for how many seconds altogether. Then we're going to make 60 a constant. So what I normally do when it's a constant, which means that throughout this whole problem, minute will be 60. Then I would want minute to be all caps, but it's not incorrect. It'll work this way. Then it says, here, let me download it because it keeps getting that other thing in the way, right? Okay, here we go. Okay, so pull it over here a little bit. Guess not. Pulled it the wrong way, didn't I? Pseudocode. Okay, so minute equals 60. So number of minutes is going to be E time divided by minute. And so we're dividing however many seconds they put in. So if, like the example said, E times equal to 130 seconds, and you divide it by 60, you're going to get 2, right? For number of minutes. And then the seconds would equal E time modulus minute, which means take the remainder. Don't use the 2 because you already used the 2 for number of minutes. So seconds would be equal to 11. So output number of minutes and seconds. So it would output the 2 and the 11. And the reason they give you some sample input and output, so that way you can test it with your logic and see if it's correct. And that's what I always do on the projects and the test, is I give you some sample input and output so that you can test it and see if yours comes up with that. And then you know if your logic is correct. Okay, anybody have any questions about this one? Oh, Patrick left, I think. Anybody? Any questions? Okay, so now we've got number 2 ready. Is that correct? We've done 3, and so Joseph has it in his. There it is. In class, okay. Okay, this one was to use the formula of area that was the number 1 problem, and then also calculate how many square tiles it would take to cover that floor length, or I'm sorry, floor area. So you had to also ask for the number of tiles up here. That's the only thing they're missing. Input length, input width, and then they should have input number of inches, is how many inches are the square tiles? Are they 6-inch tiles? Are they 12-inch tiles? How big are the tiles? So then that's why they don't have a value for this, because they didn't ask for it here. So let's take, it won't let me, I don't think, right on there. So let's, now I'm going to have to, did everybody look? Now I'm going to be in trouble. I got to do that, cut that out of my video. All right. So, well, what we need, let's quit it. Now it should be to copy and paste it. Okay. Okay, so on this one, if I copy and paste it here, let me go up to view. I'm trying to make it big enough for you to see, and that's almost giving me a hard time here. It should come up with 2. View, draft. Still not big enough. What's happening? Okay, there we go. There's more than one way to do this. Go. Okay, so this one says start, input length, input width. Oops. And then they left off one more input. So we have to say input number of inches for the tile. Input num inches is what we called it, I think. Yeah. Okay, so now they actually calculated the, let me see, I can't get it up there now. Let me see here. That's what you get for using, what I get for using Word. It doesn't want to cooperate. Num inches. Anyway, number of inches. We're going to run out of time. We got 5 minutes. Okay, so this particular one, see if I make it a little smaller, if that's what my problem is. There we go. Okay, so tile of square feet. I'm just going to type it in. Okay, so actually what I would do is I'd do the area first, which is going to be area, is that what you called it down here? No, I don't know. Area equals length. They had a double whammy. They had to do two problems at once. Okay, so then the next one, which I gave them this formula, is the tile per square feet is equal to number of inches times divided by 12 times number of inches divided by 12. Let's see. And so then what would be the last formula that you need in here, or calculation? You've got the tile per square, the number of inches divided by 12. Oh, is it divided by? Is that what I told y'all? That doesn't look right. Okay, let me call up the one that will look right. Show you which one it is for sure. This is number dollars. Let me see which one it is. Cost of the job. Lengths. Thought it was this one. Let me see. There it is. Okay, it should be like this, and so y'all can have it. I will. Okay, so this is a more straightforward way. Let's see if I can get it a little bigger. Okay, so what it would say, input width, input length, area equals width times length. And if you had asked how many inches, it would say num inches here divided by 12 times num inches divided by 12. So the number of tiles would equal this divided by the tiles per square feet. And then you would output the number of tiles. So that's how you figure. Anybody do construction in here? By like floor tiles? No? Well, I used to do that when I was in college. It was a tough job. Okay, so any questions about this? We've got about 3 or 4 minutes. We'll all put these in Python, or we can do them next time in class. I'll decide. But one thing that you need to do is in D2L is assignment 3. Remember, no ifs, no loops. Okay, it's just a sequential program. Assignment 3, do the pseudocode and flowchart and put it up on your drive before class next time, and then we will do that one. And then I'm going to introduce project 1, and you'll get some time during class to work on project 1. Number 2, let's see. Oh, is that the one that I just put up? The output is number of tiles. So if you say number of tiles is equal to the room area, however you calculated the area, divided by the number of tiles per square feet. Pardon? Oh, sure. Let me see if I was trying to do that. Yeah, and for some reason that it's not letting me zoom. I don't know what the problem is. There it is. There we go. Okay. So the only difference here that I put in there was I said, which made it a little harder also for the number 2 guys, input num inches. So down here, instead of 6, it would say num inches. And here it would say num inches. So if they entered 6, then set number of tiles is equal to room area divided by tile square feet. So whatever you get here, you take divided by, or I'm sorry, you take room area divided by the number of the tile per square feet, and that would give you the number of tiles for the room. So first thing you have to do is calculate the area. Then you have to know how many inches your tiles are. And then why did you have to divide by 12? Yeah, 12 inches in a foot. So that could have also been a constant variable up here. And that would make it more a program that would work no matter what. Of course, that's not ever going to change, right? The number of inches in a foot. So 12 is fine. It's so you type it in wherever. Does everybody follow that? You guys at the back, do you get that? Okay, y'all had a double hard one because you had to do this part too. You had to do 2 problems. Okay, any questions about what your assignment 3? And it's in the content of D2L. So if you go over here, is this the right one? No. Fundamentals, there it is. Assignments and assignment 3. Okay. All right. See you guys on Thursday. Good job.